It's day 9 of Maker Advent, which means it's day 5 of the Pi Hut's Maker Advent calendar. And there's the box, neatly camouflaged on my green cutting mat. See, day 5. What's inside? Let's open up the box. And we'll get the stuff that's inside. Oh, it's another output. We have a buzzer. And handily, this buzzer has got proper connections on here, not like the ones that I use, which have just bare wires and you've got to stuff them into breadboards or screw terminals. Right, let's have a look at the instructions and see how we use this in the code. Jump cut. Okay, so we have a buzzer connected to GPIO 13, which is the red wire over here. Black wire is connected to ground. And we're going to repeat a lot of stuff from yesterday, but we're not at the same time. So PWM, pulse width modulation. That can be used to control LEDs to make them go fade in and out, but it can also be used to control tones. So we can use it with that buzzer there to produce different tones, different frequencies of sound, different notes, and a very crude speaker. Don't get me wrong, we're not going to get high fidelity surround sound with this. This is not THX certified at all. But what it is fun. And also in a class of 30 children, it's annoying. So let's have a look at the basic code to make it go beep. This is really basic stuff, the hello world of making noise with a Pico and any microcontroller really. We're in Phony, the Pico's connected, this code is tested and it works, so I know I'm good here. There's also no typos today. Go me. Okay, so we've got from machine import pin PWM. That's really just our GPIO connection. So, okay, I want to work with GPIO pins. Oh, by the way, I want to use pulse width modulation. That's all it's saying. Time, we're going to use that to introduce a pause to the code. Then we create an object called buzzer. Our buzzer is a PWM object, so it's an output. It's on pin 13, GPIO 13. Using the PWM functional class, can't remember which one it is now. I think it's a class. It automatically sets it as an output, done and dusted. We then have the frequency. Remember we did this for the LED. So 1000 Hertz. And then the duty cycle, which is 10,000. And then sleep for a second, and then turn it all off. So if I click run now, you'll hear just a beep really quick. There you go, that's a beep done. So we've proven that the buzzer works. So we can now go on to more exciting stuff. I'll make it do some music. One moment, please. Okay, so now I've put the new example code in, which is the second one from the Pi Hut's guide for the day. This one has the same thing, same buzzer, same duty cycle to start with, the same frequency. But then we're asleep. There it is. Then we change the frequency again to 500 and then sleep. So we should get a beep, beep, beep. Let's see what happens. Okay, the Pi Hut's next example is using the potentiometer. So remember that from the other day? Analog input. So we're going to use that to control the input to the Pico, which then controls the output to the speaker, the buzzer. So pretty much similar code from the other day. Potentiometer is on pin 27. Oh, we change the imports as well, sorry. So we add ADC, analog to digital conversion. We then have the object potentiometer on pin 27. The buzzer's the same at pin 13. The reading 0, that's the initial reading when the machine first starts. While true loop, do it forever. 0.1 second delay. Take a reading and then convert it into something that the Pico can understand. Then set the frequency to 500. And then the duty cycle becomes the reading. So how long it's actually on for. So duty is how long you're on for. And then print the reading to the Python shell so we can see that it's working. So I'm going to run this code. So there you go, that's analog input to control it. Let's stop the code. Okay, and the final example that the Pi Hut provided, very festive indeed. Basic, there's no inputs on this, it's just taking the code, reading it, and spitting out noise from the speaker, the little buzzer there. So what we're doing is we have same imports, PWM, pin, time. We have the same buzzer, so we have a connection to our GPIO pin for the buzzer. And we have 4 tones. These are the notes that will play a tune. And as you can see from the code comments, it's Jingle Bells. Will I get a copyright strike for Jingle Bells played on a little buzzer from a Raspberry Pi Pico? We're going to find out. By the way, I don't monetize these videos, so it doesn't really matter. C, D, E, G. I'm not a musician. I know their notes. So there you go. Volume is set to 10,000. That's the duty cycle. So the jin part of it, of the jingle, is an E for 0.1 seconds. Then we turn it off, and then we add a 0.2 second delay. The gul of jingle is an E again, so it's did, and that's 0.1 seconds, turn off, pause for 0.2 seconds. And it seems that bells is an E as well. And so is jingle, because it goes jingle bells, jingle bells. So where do we have a key change? Gul here is a G. So what we're doing here is we're referencing these letters, the G, the E, the C, are going back to these variables that we created earlier, which store numeric values that relate to the frequency that we want to play. So when you go through all of that, it'll play a tune. So let's run it. So there we have it. We have the projects from the Pi Hut's Maker Advent Calendar for today. So that's day 5. So the next one's going to be day 6, and that's going to be in 2 days' time now. But yeah, that's all for today. See you later.